Hello, my little mathematicians. We're going to help you review the unit on expressions. So let's focus on numbers 13 through 25. Number 13 says 3 students are sitting in the first row. And then this is where it gets tricky, is depending upon how you read it. Is it saying, and then there's another 3 students behind there, and another 3 students behind there, and so on. And you want to figure out how many are in the 5th row. So 1, 2, 3, 4, 5. So technically you're like, well, is there 5 students in the 5th row? Or 1, 2, 3, 4, 5 times 3 is 15 kids total. But they asked me how many kids are in the 5th row, and there's 3. Is that what it's saying? And actually, no. It's saying you have 3 kids here. And then behind this kid, there's 3 kids. Behind this kid, there's 3 kids. And behind this kid, there's 3 kids. So right here, this is saying that it's 3 kids in the first row, and behind each one of them, there's another set of 3. So this would be 3 to the power of what to represent 3 total kids? 3 to the power of 1. This would be 3 to the power of what to represent the total number of kids? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 3 squared. Okay, so then what do you think would come next? 3 cubed, 3 to the 4th, 3 to the 5th. So in the first row, you have an exponent of 1. In the 5th row, you have an exponent of 5. So how many kids are there? 3 to the 5th power, which is what? You have 1, 2, 3, 4, 5 threes. 1, 2, 3, 4, 5. So 3 times 3 is 9. That 3 times 3 is 9, and bring down that 3. And then 9 times 9 is 81. Bring down that 3. So now you have 81 times 3. Well, 1 times 3 is 3. 3 times 8 is 24. So there's actually 243 kids in the 5th row. Okay, that was a trap answer. So you would think like, oh, there's only 3 kids in the 5th row, or there's 15 kids total. It's actually an exponential problem because behind each of those students, there's another group of 3. Let's take a look at number 14. Okay, number 14 says Allison wants to cut out a rectangle with an area of 54 inches. What are the possible whole number lengths and widths of the rectangle? Well, you're talking about a rectangle and area. What do we know? We know that length times width equals area, right? So they told me that the area is 54. So I'm going to substitute in a 54 for the A. And they told me that they told me nothing else, the length and width. So I want to know what are the possibilities. So I have to think of all the factors of 54. So 1 times 54, right? What else? Can 2 go in? Yeah, because it's even. So 2 and 27. Can 3 go in? Well, 4 plus 5 is 9, and 3 can go into 9. So I know 3 can go in. So let's do some long division there. And 3 goes in 24 8 times. So 3 times 18 is 54. 4 cannot go in. 5 cannot go in. 6 times 9. 7 cannot go in. 8 cannot go in. 9 is already used, so that's all of them. So that means these are all the possibilities that you could get to multiply to 54. So 1 times 54 is 54. 2 times 27 is 54. 3 times 18 is 54, and 6 times 9 is 54. So I could have a length of 1 and a width of 54, or a length of 2 and a width of 27, a length of 3 and a width of 18, a length of 6 and a width of, what is it? 9. Is that all the possibilities that I could do? No. Because technically I could have done a length of 54 and a width of 1, right? I could reverse the length and the width. So the length could be 27 and the width could be 2. And the length could be 18 and the width could be 3. And the length could be 9 and the width could be 6. So there's a total possibility of 1, 2, 3, 4, 5, 6, 7, 8 different combinations that I could do. And then, of course, don't forget your units. You would put your units on there. Remember to always pause the video and try things yourself if you want, and then unpause it to check yourself to see if you're right. Okay, this next one is a PEMDAS. Okay, it says, which operation should you perform first when you evaluate the expression below? Well, inside of the parentheses, you do multiplication before addition. So I'm going to do that 15 times 5 first. And 5 plus 2 is 7, so 75. And then let's go ahead and keep simplifying it. Okay, I still want to do inside the parentheses, so 75 plus 4 is 79. Bring down your times 3. And now you have 79 times 3. 21 plus 2 is 23. So my final answer is 237. Okay. Number 16. Let's go ahead and turn the page. Number 16 says, evaluate the expressions below using the order of operations. So same type of problem. 2 plus 3, parentheses 7 minus 1, close parentheses, plus 3 squared. Well, inside of parentheses first, 7 minus 1 is 6. Okay, parentheses are down to a single number. Do you see any exponents? Yes, that 3 squared, and 3 squared is 9. Bring down your other stuff. Okay, parentheses are down to a single number. Exponents are taken care of. Multiplication or division, right here. 3 times 6 is 18. And then I just have addition left. So 2 plus 18 is 20, plus 9, and 20 plus 9 is 29. Okay, number 17. Write an algebraic expression to represent b less than 50. Go ahead and write that. And what did you put? B less than. So it moves the b to the back because it said less than. If you see than or from, like subtracted from, then that moves that letter to the back. And you're taking b away from 50. So that's the correct answer. 18, you have 14y divided by 2, and you're substituting in a 6 for y. So 14 times, I'm going to replace that y with a 6. That's one term. 4y is one term. And then divided by 2. Okay. Well, 14 times 6, you have, that's 24. 6 plus 2 is 8. So you have 84 divided by 2. Well, half of 8 is 4, and half of 4 is 2. So your final answer is 42. Number 19, we're evaluating again. That just means solve. You're going to substitute in an S. You're going to replace with a 4, and you're going to replace or substitute in a 1 for the T. So this term is 8 times S is a 4. And then this term, you have 5 times T is a 1. Plus this term, S is a 4, and it's being squared. So this term simplifies to 32, minus this term simplifies to a 5, and this term simplifies, 4 squared is 16. And then when deciding between addition and subtraction, you go from left to right. So you have 32 minus 5, and 12 minus 5 is 7. Bring down the 2. So 27 plus 16. You have 13 plus 1 is 4. So that is 43. Okay. And then that was number 19. So let's go ahead and take a look at number 20. It's another evaluate problem. So you have 3 parentheses, 7 plus x squared, and x is 2. So I write everything exactly as I see it, except instead of an x, I'm going to replace it with a 2, what x is equal to. Now, within the parentheses, you need to simplify that down to a single number first. And do you do exponents or addition first? Well, PEMDAS dictates that you do 2 squared first. So 2 squared is 4. Now the plus 7 times 3. Okay, I still need to get this parentheses to a single number. 7 plus 4 is 11. And 3 times 11 is 33. Okay, I'm going to change colors just so that it doesn't blend in together. 21 says x subtracted from 15. Okay, if it said x subtracted by 15, it would be x minus 15. But because it says subtracted from, it's actually 15 minus x. Okay, because x is being subtracted from 15. When you see the word than or from, it moves it to the back. Okay, and then 22, 4 groups of y. So you have y, and you have 1, 2, 3, 4 groups of them. So you have 4 y's. Okay, groups of means multiplication. And we don't need to put 4 times y, just put 4 touching the y, and that means multiplication. Finally, let's see here, number 23 says, use a property to write an equivalent expression for the expression below and tell which property you used. So when you have a number out in front of the parentheses, you distribute that number in. Because you can't combine these guys, right? This is not like terms. So then I'm going to distribute that 7, which means I multiply it by each thing inside. So you have 7 times 3x, bring down the plus sign, and then 7 times 8. Well, 7 times 3x, 7 times 3 is 21x, plus 7 times 8 is 56. And I can't combine these because this has an x and this does not have an x. They are not like terms, so I leave it like that. 24 says combine like terms. I have 4y squared plus 6x minus 2y squared plus 12x. So do you see any other y squareds right here? Circle the sign with it because this is saying 4 minus 2y squared. So 4 minus 2 is 2. Tack on the y squared. Because when they have like terms, that means same letter raised to the same power. If this was 4y squared and negative 2y, I wouldn't be able to combine them because it's same letter to the same power. And then you combine the coefficients. So I subtracted those. These ones are both x's to the power of 1. So when you combine them, 6x plus 12x is 18x. And again, you can't combine those because they're not the same letters raised to the same power. So that is my final answer. And then our final problem, number 25, says 7x plus 4 times 2x minus 6. Well, that 7x, nothing's happening, so let's bring it down. But this 4 is being distributed to everything inside of there. So you have plus 4 times 2x, bring down your minus, and that 4 times 6. So 4 times 2x, 4 times 2 is 8, tack on the x, minus 4 times 6 is 24. And you have that 7x in front. Do you see any like terms? 7x and 8x combine and give you 15x. 7 plus 8 is 15, tack on the x, and then we just add on our constant at the end of negative 24. And that's it. That's my final answer. If you got all of those correct before we went over them, you have mastered this. You're golden.